Assalamu alaikum. We are going to start our today's lecture. Today we will discuss how to compute the deformations in beams. The purpose of structural analysis or the objective of structural analysis is based on two things. One is to study the force response or compute the critical internal forces, which are shear force, bending moment, axial force, etc., depending upon the type of the structural member. And the second objective of the structural analysis is to study the deformation response. That means to compute the deformations, deflections, rotations, etc., so that those deformations can be within the permissible limits. So I'm going to share the screen. So before we start how to compute the deformations in simple beams, there are some basic concepts related to this aspect. And the first thing is strain energy in pure tension. Now on the right side, look at this prismatic bar having cross-sectional area A, modulus of elasticity E, length of this bar is L, that is the span. Prismatic bar is one which has the same cross-sectional area throughout the length. That is called prismatic bar. So it is subjected to a force F. Now, due to and this force is applied along the longitudinal axis of this bar. That is why it is called pure tension. There is no bending because there is no eccentricity. So under this application of load F, this bar will elongate or have the tendency to elongate. Now on the left side, we study this. Consider a prismatic bar under the action of pure tension. This bar will elongate by a distance delta under gradually increasing load F. Now it means this load has done some work. This load has done some work. And this work is stored in the form in the bar. This work is stored in the bar in the form of strain energy. Let we represent the strain energy with the symbol U. Now from your earlier knowledge, you know that we apply the strain and get the stress. Stress is actually resisting internal force acting per unit area. So we apply a strain. क्या हम करते हैं? We try to elongate a bar. यही हम करते हैं ना? Either we are applying tension. What we are going to do? We are trying to elongate the bar. Or we apply the compression. What we try to shorten the bar. So we apply the strain. That is why in stress strain graph, strain is always along the horizontal axis, which are the independent axis. And the stress or the load is along the y-axis, which are dependent. So this work is stored in the bar in the form of strain energy. So the stress strain graph up to elastic limit will be like this shaded area. This is the energy stored in this bar in the form of strain energy. Now, if we want to compute this work, that what is the amount of work, then coming here, U, that is the strain energy, is equal to half F into delta. This is a triangle, so area of the triangle is half into delta into F. Now, you know from your earlier knowledge a very well-known equation, that is delta is equal to FL over AE. ये आपने पढ़ी होगी equation पहले, surely पढ़ी है. A is known as axial rigidity or axial stiffness. So now substituting this equation of delta into this equation of strain energy, we get it U is equal to half F square L over AE. This is the representation of strain energy in terms of force or in terms of load. Similarly, from this equation, if we want to compute the value of this force, this will be delta into AE divided by L. Substituting the same equation in this equation, now the strain energy will be delta square AE over 2L. This will be in the form of deformation or elongation. I think this concept is clear to you. If you have any question, you can ask. यहाँ तक कोई confusion है तो बताइए मुझे. So no confusion. Now this is the strain energy in a single bar. This is a single bar. Now in case of a truss where we have number of bars, multiple bars, truss members. For a truss comprising of number of bars, just we have done the summation Fi square Li over 2Ai into E. This is in terms of force, and in terms of deformation, that is sigma delta I square Ai into E over 2Li. So this will be in case of single bar, this will be in case of a truss member. Now, with this concept of strain energy, we proceed for Castigliano's second theorem, with the help of which we will compute the deformations of the structures. Now, Castigliano's second theorem is, if the strain energy in a linear and elastic structure is expressed as second degree function of force, ये हमने यहाँ पे देख लिया, second degree function of force है, single bar में भी और यहाँ पे भी. Then under such condition, now within this inverted commas, this is to be given more attention. A partial derivative of strain energy with respect to any of the applied load, gives the displacement corresponding to that load. This is to be underlined, gives the displacement corresponding to that load. इस strain energy को, which has been represented in terms of second degree function of the force, we take the partial derivative with respect to a particular load, जहां पे हमें उसकी deformation चाहिए. So this equation will give us the deformation corresponding to that load, not anywhere else. So this theorem is useful in calculating the deformations, displacements, deflections, rotations, etc. of beams, frames, trusses, etc. Mathematically, we can write partial derivative of strain energy with respect to a force Fn will give us the deformation at n point. Now, the same equation for a truss displacement corresponding to, say, there is a force F1. Now we want to compute the deformation corresponding to force F1. So we will take the partial derivative of the strain energy with respect to F1 because we need the deformation corresponding to load F1. So this will be sigma Fi Li over Ai into E into partial Fi over partial F1. Either we will use the equation in this form or we will use the equation in this form. That is partial capital Fi with respect to the load F1 has been replaced by small fi. Now what is capital Fi and small fi? Look at this on right side. Capital Fi, axial force in member I, where I varies from 1 to n. Capital F1, axial force in member 1. And both of these two are due to the applied load, actual loads. Whereas small fi is the axial force in member I due to unit load applied where displacement is required by ignoring the actual loads. इसकी अभी application भी आगे आ जाएगी. So don't worry about that. So I think the basic theme of strain energy and the Castigliano second theorem is understood. This is just the base. Now we proceed for the actual strain energy in pure bending. Now we have just studied this equation F square L over 2AE. On the similar line, the strain energy in pure bending, look at this beam where it is subjected to movement and the theta. So strain energy will be equal to half m into theta on the similar lines. Whereas the very well-known equation, theta is equal to ml over EI. Now substituting the value of theta in this basic equation of strain energy, this will result into strain energy is equal to m square L over 2EI. Now we know that the bending moment in a beam varies along the span. It is not constant most of the time. So it varies along the span. So a more rational representation of this equation is since the moment varies along the beam span, therefore above expression may be written as strain energy is equal to integral 0 to L, which is the span of the beam, m square over 2EI into dx. जी ये चीज क्लियर है आपको? कोई कंफ्यूजन तो नहीं है आपको? Okay. Now, again, this is the strain energy in the form of second degree function of the force. Now, this one and this one. Now, look at on the right side. Look at this right side. Now, this is a simply supported beam, and we want to compute the deflection corresponding to this load P. We want to compute this deflection corresponding to load P. Since this load is applied at the midpoint, so the reactions will be P by 2 and P by 2. Now we will apply the Castigliano second theorem. But it states, take the partial derivative of the strain energy with respect to this load P, because we need the deflection corresponding to this load. So look at this deflection, partial derivative of this strain energy with respect to P. This will become 1, ये दो इधर आ जाएगा, 1 over 2 EI integral 0 to L M partial M over partial P into dx is equal to 1 over EI integral 0 to L M partial M over partial P into dx. Either we will use the equation in this form, that is integral 0 to L M into partial M over partial P into dx, or in the form of integral 0 to L capital M into small m into dx, where capital M is the bending moment due to applied loads and small m is the bending moment due to unit load applied where deflection is required by ignoring the actual loads. Now we will understand more by solving one numerical problem. यहाँ तक कोई confusion है तो बताएं. Now we will learn from this more. We will learn more from this cantilever beam. Now this is a beam AB and it is subjected to a load P vertically downward and a clockwise moment at A. And span is L. Now it is required to compute deflection at A and rotation at A. Here, compute delta A and theta A. Since the देखें ये पहला check है. Since the corresponding loads are present, therefore Castigliano second theorem is applicable. अगर corresponding load नहीं होगा तो वो Castigliano second theorem applicable सूरत में नहीं होगा. Now for delta A, the equation will be, अच्छा अब मैं आपको एक चीज थोड़ी सी और हिंट दे दूं. Where it is more preferable to use this form of equation, that M partial M or partial P, where the general terms are there like P, M, A, and where the specific values of the loads are given, then the small m equation is more convenient to use. Now, this equation is 1 over delta A 1 over EI integral 0 to L M into partial M over partial P into dx. Now, what we have to do? We have to compute two things only. Only two things, nothing else. Two things are related to your civil engineering. Rest is the thing is related to mathematics, which you already know. So you have to compute, you have to write the bending moment expression and then take its partial derivative with respect to P. So practically you have to just do one work, that to write the general bending moment expression. So take any section at a distance x from A. Now, what will be the bending moment expression? That will be MA positive because it is creating tension on the bottom side. Then minus P into X. Why it is minus? Because creating tension on the top fibers. So M will be MA minus PX. This will be the bending moment expression, and this is valid for entire span. It means the limit is 0 to L. अगर यहाँ पे कोई और दरमियान में लोड आ जाता तो ये वाली बेंडिंग मोमेंट एक्सप्रेशन उस लोड तक ही एप्लीकेबल होती. तो that is why this bending moment equation is valid for entire span. Now what next? ये आप अगर ये आपका काम ठीक हो गया so it means now you can assume that the rest of the work may be correct provided that your calculation work is error free. So we have to take the partial derivative of this moment expression. Now as we have to take the partial derivative of this moment expression with respect to P, so we have to consider only this term, this second term. So it will be minus X. Now anybody have any confusion regarding this M and partial M over partial P?
सर M का बता दें दोबारा कैसे फाइंड किया.
और भाई ये देखो आपने A से at any distance X आपने एक सेक्शन लिया, वहां पे आपने अब इसकी बेंडिंग मोमेंट एक्सप्रेशन लिखनी है. दो ही लोड है आपके पास MA और P, तीसरा तो कोई लोड नहीं है इधर, ना कोई रिएक्शन है इस साइड पे. सो MA minus PX, देयर इज नो थर्ड थिंग.
ओके सर.
ठीक है जी. अब व्हाट इज द नेक्स्ट? अब आपने इन दो को इस इक्वेशन में नीचे लिखना है. दैट इज 1 over EI integral 0 to L MA minus PX, that is the value of M, then partial M over partial P, that is minus X into dx. Rest of the job is to solve this integral. Mathematics है बाकी engineering नहीं है, बाकी mathematics है. And upon simplification of this integral, you will come either in this form or 2PL cube minus 3MAL square over 6EI. अभी भी बता दें कोई कंफ्यूजन है तो. अब ये ना आप कहिएगा कि जी आप इंटीग्रल सॉल्व करना भी सिखाएं. जी एनीबॉडी? सो मेन काम वही दो हैं. आपने मूवमेंट एक्सप्रेशन लिखनी है और उसका पार्शियल डेरिवेटिव लेना है. अच्छा, now secondly, now how to compute theta A? Now as far as this M is concerned, this will remain the same. Only this second term will change because theta, the corresponding load to the theta A is MA. So M is same. Its partial derivative with respect to MA is 1 because we will consider the first term only. So its value is 1. Now these two things to be put in this equation. So MA minus PX into 1 into ds and just solve the integral. You will come at this MAL over EI minus PL square over 2EI. इसको फिर एक दफा गौर से देख लें, कोई कंफ्यूजन है तो मुझे बताएं. The same principle is going to be applied everywhere. The same concept, same theme. Conditions will be different.
सर ये सिग्मा m by सिग्मा m is equal to 1 कैसे आई, एक बार दोबारा बता दूं.
यार आपने मैथमेटिक्स पढ़ा हुआ है
जी सर.
तो पार्शियल डेरिवेटिव चीज का टॉपिक पढ़ा हुआ है.
जी सर.
तो जब इस इक्वेशन का पार्शियल डेरिवेटिव लिया जाएगा विद रिस्पेक्ट टू एम ए, तो ये इन दो टर्मों में से कौन सी टर्म जो है वो कंसीडर होगी.
ठीक है सर, आगे कांस्टेंट और 0 हो जाएगा. ओके सर.
तो अल्लाह के बंदे यार, ये चीजें तो अब क्या करते हो तुम.
सर सर सॉरी
जी,
सर.
एनीबॉडी एल्स, किसी और की कोई कंफ्यूजन है तो बताएं. जी, गर्ल्स स्टूडेंट्स को सब समझ आ गई है.
Yes, sir.
चले, so we proceed for second type of problem. Now look at this simply supported beam. Simply supported beam subjected to a UDL, uniformly distributed load of intensity Q, and a central or midpoint load P. So that is why up to P it is L by 2, up to C it is L by 2. So first of all, what we have to do in this problem, we have to compute the deflection at C, delta C. So first of all, we have to compute the reactions. Due to this P, it is P by 2 because midpoint pe hai, it is P by 2. Now due to this UDL, it is spanning over entire length of the beam. So it will be Q into L, total span, QL by 2 and QL by 2. This is the value of VA and VB. By this way, you will compute the reactions. So we will write the moment expression. What is that? Now take any section at a distance x from A. Now at this section, the moment will be VA into X, this one. VA into X, positive आएगा because it is creating tension at the bottom fiber. So अब ये जो top, ये जो UDL लग रहा है over span X, it will be QX into X by 2, acting at X by 2, QX into X by 2. So now substituting the value of VA, P by 2 plus QL by 2 into X minus QX square over 2. जी, इस मूवमेंट की आपको समझ आ गई है कैसे आया ये. कोई कंफ्यूजन तो नहीं है आपको.
सर ये पॉइंट सी पे पॉइंट लोड लगा हुआ है.
जी जी, आपको क्या नजर आ रहा है.
सर
मुझे
इसका मोमेंट,
मुझे तो पॉइंट लो. जी,
इसके मोमेंट की इक्वेशन क्यों नहीं लिखी हमने.
नहीं तो ये जब आपने एट ए डिस्टेंस x लिखी है तो इसमें P by P नहीं आ रहा.
सेक्शन सर लिया, ठीक है.
जी, और किसी का कोई क्वेश्चन? जी, आगे चलते हैं. So this is the moment expression M. Now, because we have to compute the deflection corresponding to load P, so we will take the partial derivative of this M with respect to P. Now we will consider the term this will be P only this first term because that is only P is here. So इसके साथ P के साथ क्या है? X by 2. जब ये X इससे मल्टीप्लाई होगा it will be Px by 2. So partial derivative of M with respect to P will be equal to X by 2. Now one thing more. This moment expression is applicable up to point C. So the limit will be 0 to L by 2. Since the loading is symmetrical, this is important to understand. चूंकि loading symmetrical है, that is why for entire span, we will multiply it with 2. अगर ये लोडिंग सिमेट्रिकल ना होती तो फिर हम दोनों पोर्शन अलग अलग लेते, पोर्शन AC एंड पोर्शन BC, फिर उनको सम अप करते. चूंकि यहाँ लोडिंग सिमेट्रिकल है लिहाजा हम सिंपली 2 से मल्टीप्लाई करेंगे. सो लुक एट दिस इक्वेशन 2, वही ये 2 हमने मल्टीप्लाई किया है. 1 over EI integral 0 to L by 2. This moment expression M, that is P by 2 QL by 2 into X minus QX square by 2 अपने हाथ से सॉल्व करें जरा. Please hurry up. Why you are taking so much time? Cameras are still not on. Only one camera is on.
अस्सलाम वालेकुम सर।
Islam.
सर आपसे एक रिक्वेस्ट करनी थी। सर मेरी
जी
तबीयत
जी
ठीक नहीं थी तो डॉक्टर से अपॉइंटमेंट ली थी 1 बजे की। तो सर आप
जी
अलाउ
जी।
करते हैं कि मैं चला जाऊँ?
हाँ आप चले जाएं, ये साथ रिकॉर्डिंग इसकी हो रही है, बाद में सुन लीजिएगा इसको।
ओके सर, थैंक यू सर,
ओ-
थैंक यू सर सो मच।
ओ- So have anybody completed the calculation work?
Yes, sir. हो गया.
So the answer is same.
Sir, आंसर यहाँ पे स्क्रीन पे शो नहीं हो रहा. थोड़ी सी नीचे करें.
Okay, okay, please wait. Please wait. Now let me know.
Yes, sir. यही है.
That's good. Or what about the others?
जी सर यही आंसर है।
यही आंसर है। देखें अब इसमें if you concentrate, so only this 1, 2, 3, 3 lines are related to the civil engineering. Rest of the work is related to mathematics. Is it so? सो अगर आपकी मैथमेटिक्स में वीकनेस है तो मसाइल हो जाएंगे। तो इसलिए ये सारी जो स्टडीज हैं ये इंटर रिलेटेड स्टडीज होती हैं सारी। सो शुड वी प्रोसीड फॉर नेक्स्ट प्रॉब्लम? Or somebody have any question to ask?
Sir, we can proceed.
Okay. Now the third problem is when we will consider these two portions separately. This is the problem. This is again a simply supported beam, and there is a load of 120 kilonewton acting at point C, which is at 1.8 meter away from support A and 3.6 meter away from support B. So clearly this beam has two portions, portion AC and portion CB. Now it is required to compute the deflection at C and rotation at A. Now first we will consider the rotation up. Now here the load value is specific. Now it will be more convenient to use small m, the equation having small m, capital M, small m into dx. How we will learn just now. So first we will consider the deflection at C. So the corresponding load is there. So it means Castigliano second theorem is applicable. Whereas when we will move towards theta at A, the corresponding load is not there. So in the current status, which can be seen on the screen, Castigliano second theorem is not applicable. How we can make it applicable, we will learn at that stage. So we will use this equation, deflection at C 1 over EI, integral 0 to L, capital M, small m into dx. So since there are two portions of span AC and BC, therefore we will proceed span wise. So portion AC. Now for portion AC, the span is 1.8, varies from 0 to 1.8. So this will be called its limit. Now from where it has to measure, that will be called its origin. So it is convenient to consider A as origin and its limits is 0 to 1.8. Now as far as its general movement, of course, before proceeding to this, we have to compute the reactions, and very conveniently 120 into 3.6 over total, that is 5.4. This will give you this reaction, and this reaction will, you can have 120 into 1.8 divided 5.4. That will give you this value of 40 kilonewton. So for portion AC, the moment will be 80 into x, positive, because creating tension on the bottom fibers. So for portion BC, surely B is a more convenient to consider as origin. So the limit is 0 to 3.6. The moment is 40 into x, again positive, creating tension on the bottom fiber. So 80x and 40x. Now small m. Now consider the same beam, but instead of 120 kilonewton, you have to apply a unit load, one. So on the similar lines, this reaction 0.67 and this reaction at B, that is 0.33. Again, the same theme, 0.67x and 0.33x. कोई confusion आपको यहाँ तक? Anything which is not understandable?
सर 0.667 और 0.33 रिएक्शंस हैं वो जो ए और बी पे लग रहे हैं।
तो भाई और क्या आएगा? जब आपका लोड A1 का लगा हुआ है तो उसके बराबर रिएक्शन नहीं आएंगे, दोनों को जमा करें तो उसके बराबर आएंगे रिएक्शन, तभी ये स्टेट ऑफ इक्विलिब्रियम में होगा।
ओके सर।
जी, anybody else? So now what is this is the value of E and value of I in the compatible units. So what is next? That is just to substitute in this equation. Once for portion AC, once for portion BC. This first part is 1 over EI integral 0 to 1.8 ATX into 0.67x into dx. This is for portion AC plus integral 0 to 3.6 40x into 0.33x into dx. This is for portion BC. Rest of the job is to solve this integral. करें जरा इसको solve करें जरा. Please hurry up. जी, please hurry up. Have anybody completed it?
जी सर.
So same value you have got.
जी सर, सेम वाली बारी है.
So we proceed for theta A. As there is no corresponding load moment, therefore in present condition, Castigliano's second theorem is not applicable. To make it applicable, if fictitious means imaginary, fictitious corresponding moment MA is applied, then we can proceed. Now look at this beam. Now this fictitious load and the reaction due to this fictitious movement are shown by red color. So let MA is acting at A. Rest of the work is the previous one, 80 and 40. Now due to this load, due to this movement MA, two reactions will come. Since it is clockwise, so this balancing movement will be counterclockwise. How much? This MA divided by 1 plus 8 plus 3.6, that is 5.4. So MA divided by 5.4, MA divided by 5.4. Then this beam will become in the state of equilibrium. We will use either this equation or you can use small m. Both options we can adopt. So again, we have two portions. Portion AC with same origin, same limits, but the value of the moment expression will change. It will be 80 minus this MA plus 80 minus MA divided by 5.4 into X. This one, MA plus 80 minus MA over 5.4 into X. Similarly, for portion BC, it will be 40 plus MA over 5.4 into X. 40 plus MA over 5.4 into X. Now the partial M over partial MA or small m, both I have shown here. This will be, now we look at the term with MA, that is 1, that is minus X over 5.4. So partial M over partial MA will be 1 minus X over 5.4. For portion BC, it will be simply X over 5.4. Any confusion for this M and partial M or partial MA? Any question?
सर M का बता दें दोबारा.
भाई M का आप देखें ना, आप यहाँ मूवमेंट ले रहे हैं. This MA as it is. अब ये जो चीज है 80 अपवर्ड है, ये है 80 माइनस MA over 5.4 विद इन ब्रैकेट इनटू X. यहाँ इसमें मुश्किल है.
ओके सर.
जी, anybody else? Now what next to do? Just put in the equation, in this equation for portion AC and portion BC. So theta A1 over EI integral 0 to 1.8 80 minus MA over 5.4 into X plus MA, ये हमारी M की वैल्यू आ गई into 1 minus x over 5.4 आगे partial m और partial m में into dx. This is for portion AC. Then for portion 1 over EI integral 0 to 3.6, 40 plus MA over 5.4 into x into x over 5.4 into dx. Now at this stage, we have to equate MA equal to 0, being fictitious. चूंकि ये fictitious था, लिहाजा हम इसको 0 के बराबर इक्वेट कर देंगे. And rest of the expression will be solved. उसको भी जरा प्लीज करें. Please hurry up in next 5-6 minutes. G, have anybody completed? जी ये इतना लंबा होना नहीं चाहिए.
सर हो गया कंप्लीट.
The answer is same.
यस सर.
What about boy students?
सर हो गए.
So all these problems which we have discussed in this lecture that you will do with your own handwriting, along with there are some other problems given in the book by Hibbeler. उसमें से भी इस problems को देखें. Then we will meet on coming Monday. So till that, that's all for today. Thank you very much.